Hi all, myself Professor Disha Shukla and I am conducting the subject Wireless Communication. My today's topic is CDMA channels. Now CDMA channels has both forward channels and the reverse channel. But before that, what is a CDMA channel? A code channel is a stream of data designated for a specific use or a person. These channels may be voice data or it can be an overhead control data. In a CDMA system, channels are separated by the codes and these channels are broadly categorized as the forward and the reverse channels. A CDMA channel is a pair of 1.25 MHz frequency band that is separated by a guard band. The guard band may be 45 or 80 MHz wide. Now the pair of 1.25 MHz band is located either in the 82 to 893 MHz range in case of a cellular CDMA or in 1850 to 19089 MHz in case of a PCS CDMA. The guard bands used in the cellular is 45 MHz for PCS and it is 80 MHz for the longer range. Now a CDMA channel is in the cellular band is a pair of frequencies that are 45 MHz apart. So basically CDMA channels is a stream of data that is used for a specific person or for a specific reason. Now what do you mean by a CDMA forward channel? So CDMA forward channel means it uses the same frequency spectrum as the AMPS, that is 869 to 894 MHz. One channel bandwidth is 1.25 MHz. The modulation scheme that is used is QPSK, that is the Quadrature pulse shift keying. The orthogonal Walsh codes are used in a CDMA forward channel. Walsh codes are called the Hadmard codes and they are used in all the CDMA techniques. Forward channels are separated from each other using the different spreading codes. 64 Walsh codes are used to identify each channel. Now this is how a IS95 forward channel looks, that is the CDMA forward channel looks. Now here, as you can see, there are different types of the forward channels, that is the pilot channel, sync channel, paging channel and traffic channel. So all of them have different functionalities to be taken care of, and this is how a whole CDMA link is established, or how a whole CDMA channel is established. Say for the first one is the pilot channel. It provides the phase for coherent demodulation, time, signal strength, comparison with the reference signal for determining when to hand off for all the mobile station. That is, it provides the phase for coherent demodulation, that is the demodulation that has to be done at the receiver side. It provides phases for time, for signal strength, for comparison with the reference signal for determining that when a particular mobile station needs to be hand off. It is used to uniquely identify the sectors or the cells. The cells and the sectors can be uniquely identified using the pilot channel. It is 4 to 6 decibels stronger than all the other channels and it is used to lock onto the other channels. It is obtained using all the 0 Walsh codes, that is, it contains no information except the RF carrier. It only contains the information regarding the RF carrier. The next is the sync channel. Now it is used to acquire the initial time synchronization. That is, whenever a particular message is passed or whenever a particular communication initiates, it requires some initial time synchronization and it is done using the sync channel. Sync message includes system ID, the network ID, the offset of the PN short code. PN is the pseudo number, and the paging channel data rate. All these things are included in the sync message. It includes the system ID, system that you are using, its ID, the network ID, the offset of the pseudo number short code, that is the pseudo numbers that code that we are using, its offset, and the paging channel data rate. It broadcasts the async message to the mobile station and operates at a 1200 beats per second. it uses Walsh code 32 for spreading the particular code, that is the spread spectrum that we do. The next is the paging channel. There are 7 paging channels that are used to page the mobile station in case of an incoming call or to carry the control message for a call setup. It uses a Walsh code 127 and there is no power control. It is additionally scrambled by a pseudo number long code which is generated by LFSR of the length 42, and it operates at a rate of 4.8 kilobits per second to 9.6 kilobits per second. So this is the paging channel. It is used to page the mobile station in case of an incoming call, that is to keep the logs or to keep the data regarding each and every call, or to carry the control message for the call setup. If whenever a call has to be set up, to initiate it or to keep the different data regarding it, all these things are done using the paging channel. The next is the traffic channel. There are 55 traffic channels that are used to carry the actual information. Now we have seen the different channels, that is the pilot channel for carrying some pilot data, for the sync channel for synchronizing the data. Then this is the actual channel, that is the traffic channel. It will be carrying the actual data that we want to transmit. It supports variable data rates, that is the data rate set of 9.6 to 4.8, 2.4 and 1.2 kilobits per second, and RS2, that is the second set of the data rates, is 14.4, 7.2, 3.6 etc. kilobits per second. RS1 is mandatory for IS95 channel, but the support for RS2 is optional, and it also carries the power control bits for the reverse channel. This is how the forward channel modulation process takes place. That is, the user data is added from the base station from over here, then the convolution encoder and a repeater is used. It will be again sent to the block interleaver, then the data scrambling is done, then this is something that controls the power, and here the Walsh codes are added, and finally the data is sent using this part. Now here the pseudo number will be added to the long code generator, then a discriminator is used, and the discriminator will add the data while the data scrambling is done. Now let's see each and every process in detail. So the first one is convolution encoder and repetition. The speech coded voice or the user data is encoded using half rate convolution encoder with the constrained length of 9. The speech coder exploits the gaps and pauses in the speech, and it reduces its output from 9600 bits per second to 1200 bits per second during the silent period. That is, what does it do is the speech coded voice or the user data is encoded using the half rate convolution encoder. That is, it will encode the data that we have using the half rate convolution encoder, and the constraint length used will be 9. The speech coder will exploit the gaps and the pauses in the speech. Say for example, whenever the data is sent, suppose there is some gap or pauses in that particular speech, then it will be reduced. Those speeches will be, or those pauses will be reduced, and its output will be reduced from 9600 bits per second to 12000 bits per second during the silent period. Now whenever the user data rate is less than 9600 bits per second, each bit is repeated to maintain a constant symbol rate of 19.2 kilobits per second. The next process is the block interleaver. Now in this process, it makes the data block of 20 ms, that is 20 milliseconds, in a random way. That is, consecutive bits are not in the same block. So the block interleaver, it makes the data blocks of 20 ms in a random way. That is, there won't be any consecutive bits in the same block. It maps the data bits in a 24 by 16 matrix, and then it transmits it in the column wise. This procedure is helpful in recovering the data back in the block if lost during the channel transmission. Now what does a block interleaver do? It makes the data blocks of 20 milliseconds in a random manner. That is, it's not necessary that the consecutive bits will be in the same block, and then it creates the block using the 24 into 16 matrix. I mean, it will be mapping the data bitwise in 24 into 16 matrix, and then it will be transmitting it in the column wise. How does it help? Now say for example, if while transmitting some data or some block is lost, then it will be helpful in recovering that particular block. So that is why the block interleaver is used. The next process in the modulation is the long PN sequence, that is the pseudo number sequence. In a forward CDMA channel, direct sequence is spread spectrum is used for data scrambling. A long pseudo number sequence is the user specific code of the period 242 to 1242, that is one chip. A pseudo number sequence is generated from a 42-bit code, also known as the public mask. This is called the public mask. A public mask is specified as M41 through M32 in a set of 11001100 and M31 through M0 in a set of mobile station ESN bits. Now this is how the ESN bits are used or are set up. That is, we have an ESN E31 to E0, then a permuted ESN will be from E0 to E9. So this is how the pseudo number will be generated and the sequence will be added. Now what happens at the data scrambler? It is performed after the block interleaver. The 1.2288 megahertz of pseudo number sequence is applied to the decimator, which keeps only the first chip out of every 64 consecutive PN chips. It will be keeping only the first chip out of all these 64 consecutive PN chips. The data rate from the decimator is 19.2 kilobits per second, and the data scrambling is performed by modulo 2 addition of the interleaver output with the discriminator output symbol. That is, the decimator's output symbol and the output the output or the data that we have, both of them will be data scrambled using the modulo 2 addition. That is, we have an output from an interleaver and we have a decimator output. So both these things will be added using the modulo 2 addition, and that process is called data scrambling. The next process is power control subchannel. The power control measures are sent by the base station every 1.25 milliseconds. The power control commands are set to raise or lower its transmission power in 1 dB steps. If the received signal is low or 0 is sent over the power control subchannel, instructing the mobile station to increase its mean output power level. If the mobile's power level is high, 1 is sent to indicate that the mobile station should decrease the power level. That is, if the received signal is low, then 0 is sent for the power control. So what happens is, the power control subchannel will be instructing the mobile station to increase its output power level if a 0 is, that is, a low bit is passed, and if 1 bit is passed, then it will indicate that the mobile station should decrease its power level. And the last process is the orthogonal covering. The orthogonal scrambling is performed following the data scrambling on the forward link. Each traffic channel is transmitted on the forward CDMA channel is spread with a Walsh function at a fixed rate of 1.2288 MCPS. The Walsh function consists of 64 binary sequence, each of the length 64, which are completely orthogonal to each other, and it provides orthogonal channelization. After orthogonal covering, quadrature modulation is performed on the particular data. So this is how the whole modulation process works for a CDMA forward channel. Now moving on to the next part, that is the CDMA reverse channel. A CDMA reverse channel is using the frequency band of 869 to 894 megahertz. The bandwidth of each of this channel is 1.25 megahertz. The reverse link is separated from the forward link by 45 megahertz, and there is no spreading. That is, there is no we don't need to spread there is no spreading of the data symbols using the orthogonal codes. Instead of the orthogonal codes are used for waveform encoding. That is, here the spreading is not done using the orthogonal codes. Here the orthogonal codes are used for waveform encoding. The spreading is carried out by 42-bit long pseudo number codes. After spreading, they are further scrambled in the phase and quadrature phase by pseudo number spreading codes. The modulation scheme that is used is OQPSK, that is the orthogonal quadrature pulse shift keying. Now this is how the reverse channel works, that is the IS95 reverse channel. Now there are two types of reverse channels, that is the access channel and the reverse traffic channel. Access channel is a random access channel with each channel uniquely identified by their long codes. There are 32 access channels per reverse channel. It works at a fixed data rate of 4800 bits per second. It allows a mobile to communicate with the system for registration, call for registering for a call origination, that is to initiate a call. It allows a mobile to communicate with the system for registering so that it can initiate a call. And the reverse traffic channel, it carries the traffic from the mobile station to the base station, and it operates on a variable data rate. Again, this is operating on different data rates. Now this is how the reverse channel modulation process takes place. The first phase is convolution encoder and the symbol repetition. The convolution encoder used in is the rate of 1/3 and the constraint length is 9. In the forward channel we used 1/2 rate and the constraint length was again 9. The coder bits after convolution encoders are repeated before interleaving when the data rate is less than 9600 bits per second. And after the symbol repetition, the symbol rate out of the coder is fixed at 28,800 bits per second. The first process is of the block interleaver. Now a block interleaving is performed following the convolution encoding and repetition. The block interleaver spans 20 milliseconds and is an array with 32 rows and 18 columns. The code symbols are written into the matrix by the columns and read out by the rows. That is, block interleaving is performed following the convolution encoding and the repetition. After the previous process it is done. The block interleaver will be spanning 20 milliseconds in an array with a 30. It will be spanning the whole data that we are sending in 32 rows and 18 columns. The code symbols are written into the matrix by the columns and it will be read out by the rows. The next process is again the orthogonal modulation. A 64 array orthogonal modulation is used for a reverse CDMA channel. One of the 64 walls function is transmitted for each group of 6 coded bits. Within a walls flash, 64 walls chips are transmitted at the rate of 307.2 kilobits per second, that is 28.8 kilobits per second into 64 walls chips divided by 6 coded bits, that is 307.2 kilobits per second. The fourth process is the variable data rate transmission. The variable rate of data is sent over a CDMA reverse channel. Data in each 20 millisecond frame is divided into 16 power control group, each with a 1.25 milliseconds. That is, the whole data is divided into 16 power control groups. Some are gated on, some are gated off. The data randomizer ensures that every repeated code symbol is transmitted exactly once. That is, each and every time a particular symbol is transmitted, the data randomizer will be ensuring that the repeated code symbol is transmitted only once. The data burst randomizer generates a masking pattern of zeros and ones that will randomly mask the redundant data that is generated by the code repetition process. It will be masking. The data burst randomizer will generate a masking pattern of 0 and 1 so that the randomly generated or the redundant data that is generated by the code repetition process can be reduced. For the data rates in 9600 bits per second, 4800 bits per second, 2400 bits per second and 1200 bits per second transmission occurs on all 16, 8, 4 and 2 power control groups respectively. That is, for the 9600 bits per second we use a 16 power control group. For 4800 bits per second we use an 8 power control group and respectively. The next process is the direct sequence spreading. The reverse traffic channel is separated by long code pseudo number sequence which operates at a rate of 1.2288 MCPS, and each waltz chip is spreaded by 4 long code PN chips. And the last process is quadrature modulation. That is, prior to the transmission, the reverse channel is spread by I and Q channel pilot pseudo number sequence. The pilot sequence are used for synchronization, and the reverse link modulation is OQPSK. The data rate or the data spread by the Q pilot pseudo number sequence is delayed by half a chip with respect to the data spread by I pilot sequence to improve the spectral shaping and synchronization. So this is how the quadrature modulation will be used in the reverse channel. So if you have any questions you can ask me, but this is all about the CDMA channels, that is the CDMA forward channel and the CDMA reverse channel.